Welcome to the DD1324 online lectures. In this lecture, we are going to cover characters, strings, and arrays. C is a statically typed language, and that means that the data types cannot be left ambiguous before variables are used. One of the main reasons of having these data types is to make sure that we always use the variables in the way they're intended. We must always declare the type of every variable in C at the top of the current block scope, and every variable must be declared with a type and an identifier. The type of the variable determines how much space it occupies in memory and how the bit pattern is stored and interpreted. Here we have two example declarations. First, the type is declared the external integer, and an identifier is given I. Here we have a declaration at the same time as a definition. We declare an integer I and we assign a value of 6 in the definition. In the previous lectures, we already saw the various types of primitive and fundamental data types, including integer types and floating types. Today we'll look at the character types as well. We will also look at user-defined data types such as typedef, enum, struct, and union. And we will also look at derived data types like arrays and pointers, and also the void data type. Characters in C are not actually implemented as characters, but rather as an integer data type. In fact, it's the smallest integer type, but otherwise it's similar to an int, short, or long. Strings are arrays of char data types. A char is the smallest addressable unit of memory that can contain a basic character set. It's stored as an integer but interpreted by the compiler as an ASCII character. It's typically 8 bits long. You can define a character with the type char and then an identifier like my letter, and then always enclose your character with a single quote on either side. So here we have the character capital C, which is equal to the integer value of 67, or A, which is equal to the value of 65. You can use operations on these as if they were integers. So you can check and see if C is greater than A, and this will return true. And you can also add 2 to A, and that will give you C. You also have signed chars and unsigned chars, just like you have signed chars and ints. And these take ranges between -128 and 127, or 0 and 255. When using printf, the format specifier for a char is %c, and it's %s for strings. In C, a literal defines a compile time constant whose value is specified at the source file and which the program may not alter during execution. Whenever you define a character or a string using quotes like single quotes or double quotes, you're defining a character or a string literal, and you won't be able to modify that later in the execution of the code. Let's compare quickly the difference between a character literal or a character constant and a string literal or a string constant. First, a character constant is enclosed within single quotes, and it has a maximum length of 1. In contrast, a string literal, or an array of characters, is a sequence of characters enclosed in double quotes. It can just be A with the double quotes, or it can be a string of arbitrary length. A single character string constant has an equivalent integer value. So for example, the character A has an integer value of 65. But a string, which has many different characters, which is an array of many different characters, does not have an equivalent integer value. So you can't make any kind of comparisons with a string directly with mathematical operations. A character constant consists only of that character. So the character A consists only of the character A in single quotes. In contrast, a string always assigns, even if it's just one letter, so if you just have the character A, but you define it as a string with double quotes, then the null character will be assigned automatically to the end of a string. In any string, you always have the null character at the end, which denotes that the string has terminated. In addition, you have several useful escape sequences or special characters that are useful within strings or as characters themselves. These are denoted first by a slash or a backslash, and then one of the standard characters like A, B, F, or N. The most useful are probably /n for new line and /t for tab, and these you'll often be using within a printf statement. An array is a kind of data structure that can store a fixed size sequential collection of elements of the same type. This can be ints or chars or floats or whatever you like. Arrays reside within a contiguous block of memory. One useful way to think about an array is as a collection of variables of the same type sitting in a row inside of the memory. If you want to declare an array, first you have to specify the type of the data that's in the array, then give an identifier, and then the size of the array. So for instance, you can make an array to hold the Fibonacci sequence up to 5 digits, saying int Fibonacci of 5. You can also initialize the array after you've declared it by saying Fibonacci is equal to 1, 1, 2, 3, 5, with the curly braces denoting the beginning and end of the array. You can also combine the declaration and the initialization into a single statement where you could say int Fibonacci, and now you no longer need to specify the length because the compiler can infer it from the literal you give, which is 1, 1, 2, 3, 5. You can access the elements of the array using the square braces and specifying the element of the array that you want. So if you want the first element of the array, you use the number 0, or the second element, the number 1. So you're using 0 indexing for arrays. So in the Fibonacci sequence inside of memory, it looks something like this. In the first place, you have the number 1, and the second 1, then 2, 3, and 5, and you can access these with the indexes 0, 1, 2, 3, and 4. If you wanted to find the memory footprint of this Fibonacci sequence within your computer's memory, you could do that using the command sizeof. In my computer, each int is 4 bytes, so the sizeof returns a total value of 20 bytes. Let's now work an example where we're going to see different ways that we can operate and manipulate a string. So let's start by making a simple C program to define a string and to fill it with some characters. We'll begin by including stdio.h so we can have access to the printf function, and we'll make our main function. And now we can define a string. We'll call it letters, and we'll give it length 4. Okay, and now let's first try printing this out the kind of long way. So print using char. So we can say printf, and then we can say percent. We have to put the double quotes, %c, 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 /n. And now we're going to print out each element of the string one by one. So we'll say letters of 0, letters of 1, letters of 2, and letters of 3. Okay, and now let's fill the array the string array with some content. So we'll say letters of 0 is equal to the char k. Letters of 1 is equal to t. Letters of 2 is equal to h. And now letters of 3 is equal to /0, the null character. Right, so we can save it, and then we can go to the terminal. And at the terminal, we can say gcc example 3-1.c -o example 3-1 example 3-1, and it prints the string kth. So that's good, but it was a very long way to write kth. So let's try and do something a little bit smarter now for printing it. Instead of printing it one character at a time, we can do it, an easier way. So I can type printf, and now I can just do %s to do the whole string /n, and then letters. And now if we switch back to the terminal, we can compile again and run it. And so it works exactly the same. So now, why don't we make another array and we can fill it with numbers. So let's say char numbers is also length 4. And we can define it down here. And we can say numbers of 0 is equal to 75. Numbers of 1 is equal to 84. Numbers of 2 is equal to 72. And numbers of 3 is equal to 0. So now it's important to remember that that chars as a data type are just a special kind of small integer. So what we can do now is say printf %s/n have a small typo. And then we can go back to the terminal. I mistyped printf. Let's fix that and save it. Okay. And now you can see that so it printed out KTH again. And so these values that I wrote, 75, 84, 72, and 0, are KTH and the end of string, or the null character, which denotes an end of string. So you can also do some math on this array. So we could do, let's do some quick math. And we can do it inside of the printf. So we can do a printf and then go one character at a time, /n like before. And now we can say letter of 0 plus 32 letters of 1 plus 32 letters of 2 plus 32 letters of 3. Okay, so we can save that and then go back to the terminal, and let's see what happens if we compile. So by adding 32, what we did is we shifted around inside the inside the ASCII character set to the lowercase letters. So by adding 32, we went from capital A to lowercase a. So yeah, that's also an interesting thing you can do. I don't think you would want to do that very often in practice, but yeah. So now of course the easiest way to define a string is to just do something like this, to say char str array and give it a literal. So if we wanted to define this same array, we would just do something like this normally. Printf of %s/n. So now we've defined a string literal, and it's just 2 lines to define it and print it. Oh, I must have had a typo. Let's see what that was. There is no misspelled array. Okay, so let's fix that typo. And now I can try compiling again. Yeah, and so that's the easiest way to do it. And that concludes our online lecture for characters, strings, and arrays. Thank you for watching.